Hello everybody, this is Coroutine and Flow equals MVI love. So my name is Etienne Caron. I want to say quickly thank you to my employer who allowed for me to be here today, and also a quick shout out to the Google Developer Expert Program, of which I'm part of. So thanks to Google for helping me be on stage today and providing resources and a lot of good counseling and all that good stuff. So also a very big thank you for the conference organizers. droidCon New York is awesome, and I'm very, very happy to be here. And let's get started. All right. Personally, I discovered the MVI pattern a few years back on Hannes Dorfman's blog. The link is right here below. So the general idea of MVI is that you have a view where your user is interacting with, and view events come out of this, right, and get turned into intents, which are in turn consumed by your model. And when your model gets changed, your view itself starts consuming that. So this is the reactive MVI pattern in a nutshell. So what's so special about this anyway, right? There's a few key features that are super interesting. It relies strongly on functional programming principles. So in mathematics, functions have important properties that we want to carry over into our program. Put very simply, think of when you call a function with a given property x, then you expect to always get the same value back. And the other big feature we want to carry over into our programs is that when you call a function, it should preferably be side effect free. All right, so one nice way to mostly get rid of all the side effects is by making our function arguments and return values immutable. So in an object-oriented and functional programming world, an immutable object is an object whose state cannot be changed. So that's in contrast with a mutable object, as you guessed it, that can actually be changed and will change under you for no apparent reason, right? So that's what you get from using immutable objects. The second key feature of MVI here is that it relies on reactive programming principles. Since the objects are immutable, it's safe to pass them around to other components that you don't necessarily know what they're going to be doing with your value and your state being passed around. So that allows you to focus on one problem at a time and really boil down like each little problem in its own way. And then doing this, you can compose your logic in interesting and fun ways afterwards. Since you don't need to worry about side effects, you can compose your functions together to get a lot of more mileage out of your code. All right. Personally, for a few years, I've been using RxJava as my reactive stack of choice. Maybe a quick show of hands, who here is familiar with RxJava? Right? Everybody's used it in some way or matter at this point. So I personally like it a lot. It allows for safe parallelization of work. It gives you a super powerful API to manipulate streams of events. It gives you a good control over threading, so you can offload heavy work to the CPU or IO dedicated threads, and keep other things like view updates on the main thread. So RxJava is really great. There are a few caveats. So it has a high learning curve. I don't think that's a controversial statement. When you're new to it, it kind of seems like witchcraft. The barrier to entry is high enough that it discourages newcomers, and that in turn makes it kind of hard for organizations to adopt it wholeheartedly when they're not too sure that the new interns coming in are actually going to be able to sort of play with this stuff, right? Library size. It's 1.5 meg. That's not huge. I hear the typical web page nowadays is about a meg, so it's not that big, but it's still significant. If you're thinking of it in terms of trying to build an instant app, for example, that kind of weight can easily put you over the limit. The other thing that's kind of challenging is lifecycle management. So you need to keep track of subscriptions. You need to dispose of them when you're done. It seems simple enough here, but if you start thinking about the whole Android lifecycle, having to keep track of each individual subscription, making sure that you subscribe and dispose at the right time, and so on, it's kind of easy to make a mess of things. And I'm pretty sure people here in the audience have, like me, made a mess of subscriptions and leaked a few here and there over the years, right? Okay, so we're going to see how that compares to coroutines and flow. Well, thanks to coroutine scope and a few structured concurrency principles, the story around lifecycle management is really good. Now, you still need to be deliberate about managing the lifecycle of certain things, right? We're still on Android. There's still such a thing as pause, resume. So you might need to cancel some subscriptions between those cycles in certain places. But the thing with coroutine scopes is that it helps you get a lot of that right off the bat. Weight-wise, if you take a quick look at the coroutine jars, well, it's not much of a problem. It weighs in at about 160K for these two APKs, right? Wizard refactor, it's kind of like, yes, it's also a reactive stack. It's also an asynchronous management system. I mean, this stuff is not necessarily simple, right? Well, the way I like to think about it at the end of the day is not which one is easier to learn, because that's not really the point. Like, which one gives you the most return on investment? Like, you're going to spend time learning how to do asynchrony properly and handle reactive flows. Regardless of the library, which one is going to carry over the most? So if you think about Kotlin, it's a language thing, right? So RxJava is a nice library. It's an add-on. It weighs a certain weight. Whereas with Kotlin and coroutines and Flow, if you learn this stuff, I mean, it's going to come with you wherever Kotlin goes, right? So the return on investment is kind of interesting there. I don't necessarily think one is super superior to the other right now. Flow is rather new, coroutines as well. But they're definitely on equal footing, and the time you're going to put in to learn something that's part of the language is definitely time well spent. All right. Enough of that. So we're going to get back to reactive programming as a concept and start looking at building an application with this. So reactive programming is a type of programming concerned with data streams and the propagation of change. So what does that actually mean for an app developer? So if you think of a mobile app as a reactive system, first off, your app is going to render to the device screen. Then the user sees that, thinks for a moment, and is going to do something about what they're seeing on screen. Press buttons, interact with different UI widgets. So when that happens, you're going to get some outputs basically out of that function, if you will, right? So you can then send those events to your app. It's going to process these touch events. It's going to update its internal state, update the display, and so on, right? So the loop is started. The user's input are what drives everything in this model. Whenever you hear the word reactive, I suggest you think about this little diagram. All right, so if you translate that idea to MVI, you can almost think of the view as a placeholder for the user in this system. So events coming in from the view are going to be translated to intents. Intents themselves are going to be processed by the model. The model is going to update, and then that in turn will be passed on to the view, and the view will re-render itself with new information. So we're going to start digging in. This is our sample app for this talk. I've called it Upvote. So in this app, when you press a button, it's going to increment a hearts counter or a thumbs up counter. So when the user presses the button, we're going to be emitting what we call a view event. So that's going to trigger the whole intent to model to view loop, and our screen counter is going to get updated. So if we press again, it gets updated by 1 again. So what are we exactly sending out when we're pressing that button? So to keep things nice and tidy, I typically bundle up all the signals that you can get from one view or an activity or a fragment into one sealed class, right? So here I've called that one main view event. And here there's 2 possible events, 1 per button. Very simple. So now I'm going to start using Kotlin Flows to generate asynchronous streams of value. And I'll be stealing an RxJava convention here to sort of show how this works. Marble diagrams, I find them super useful, and they sort of put a bit more concrete into, something that's kind of very theoretical, if you will. So if you start thinking of the flow as a stream of events, this is its marble diagram. Every time the user presses a button, we want a new view event to be emitted by that flow. So how do we build a flow of view clicks when the clicks are actually callback based? How do we bridge those 2 worlds? So we're going to look at that in a sec, right? All right, animation done. Okay, so this is how we can get to it. This is the callback flow function. So this is a builder function that Kotlin provides. If you're using it, it allows you, by creating a listener, to pass values through the offer call. So right here, we create that listener. And whenever the listener gets invoked, we're going to be calling offer. Offer is a function of the producer scope in which we're operating right now. So this is a channel. under the hood. So every time the user clicks, we offer a unit on that channel. Now the other key part when we're building this flow is that we need to call await close before the end of it. So what await close will do here is it'll make sure that we don't immediately leave the handler, the block. So without this, what would happen is that we'd set the listener up and then we'd quit and the flow would be over. So you need to call await close, and that tells the flow effectively to wait until either it gets closed and before it will reset the click listener, as you can see here. So what I should mention here, before I forget, is that this is an approach I pretty much stole from Zach Swear's Catch-Up GitHub project. Like all the links and references and a lot of documentation is on the Upvote GitHub project, and I'll be providing a link to that a bit later. So yeah. All right. So we now have a pattern to turn Android views, like buttons, into flows. Like we took the simplest one, but you could see how passing in any type of value, like if it was a text field, you could just pass the text change. So this approach applies to basically everything. So once we have that, we need to call our clicks extension function on our buttons. So if you're thinking that unit is a bit odd, you might not be familiar with reactive programming, we're passing units because a click carries basically no data, right? If it was a text view change, as I mentioned earlier, this would be a flow of strings, for example. All right, so to end up with a flow of main view events and not simply units, we're gonna need to do a little bit of work here. So first off, if we take the thumbs up button as an example, I'm gonna start with a click call, right? And I'm gonna be mapping this to my main view events, thumbs up click. So I take the clicks flow and I add an operator to it, the map operator, and I take the unit, well basically I don't do anything about the unit, I just turn it into a thumbs up click right there and then. So by doing this, we're gonna turn that unit into a proper view event. So it's a similar process for the other button. We have to map it to the proper signal, so the proper love it click view event. By doing this, we get a second piece of our puzzle. Things are looking good so far. So we're gonna start thinking about how do we merge these different streams. So what we want is a flow of the parent sealed class only, right? We just wanna have to deal with one source of events here. So we're gonna be doing this by taking a list of event flows and flattening it into a single one. So we're gonna dig a little bit in the code here, right? So this is what it looks like from the activities point of view when we're gonna be merging these events. So this view events function is gonna provide us with our flow of view events. Now so first thing that we're gonna be doing is creating a list of flows. Just a plain old list, a collection, nothing fancy here. You can see that we've applied our mappers, so they're already properly mapped. Now to merge these two things together, we're gonna pull a little bit of trickery. If you're aware of RxJava, it's slightly simpler in RxJava, it's one function call, but nothing crazy here, we just have a couple more steps. So we take our flows collection, a collection of flow or list of flow, and use the asFlow extension function on it, which will turn it into a proper flow of flows, right? And we don't actually want a flow of flows, we want a flow of view events, so the next step is to call this other function called flatten merge. Now flatten merge is a bit special because we need to give it a concurrency, a concurrency parameter to tell it how many flows should be collected at the same time. Now it's fairly important here to note that I'm taking the exact amount of flows we have in input because I want them all to happen concurrently. I don't want them to be parsed one after the other. There are other ways of flattening flows of flows, but those will sometimes, most of them will line things up in order, and that's not what you want. You want to have basically what amounts to a hot flow when you register to all of this. Okay, so that's how we merge different flows. Now we're gonna make things a little bit more formal. We're just gonna create a view event flow interface on this, right? So that every component that emits view events will have like a very tightly defined way of doing so, right? It's not gonna be a mess all over the place. We know that view X emits these type of events and there's only one place to get them, just to keep things tidy. So now we have that stream, we need to think about transforming those view events into something like intents that will be parsed by our model. So we first create a coroutine scope for our activity. Next step very naive lifecycle here. We're going to cancel that coroutine scope when we hit onDestroy for the activity. Like a lot of you with experience will basically say, oh, but I'd like to control that scope a little bit better. Obviously, when you're on pause, you might not always want to send events to the view, right? There's no point in making that happen. So you're going to need to think about setting up stronger life cycles depending on your use cases. But for now, this suits our purposes perfectly. So next up, once we have our scope lifecycle set up, we can start launching coroutines safely. Now, this is typically how you see coroutines being launched. You have your scope, your launch function, and then you pass it a block that will become that coroutine and will be launched, and we'll get a job in return, which we don't need to track, thankfully, because scope is aware of its children and just keeps a reference to that on its own. When we call scope cancel, everything will happen nicely and tidy, right? That's kind of a little bit verbose, right? But anyway, we'll just run through it and see how this works. So when you call collect on a flow, if you're not familiar with how flows work, what you need to be aware of that it's a suspend function, right? So that's the reason you need to launch a new coroutine to handle this. You don't want to basically stop your onCreate, suspend your onCreate when you call collect on the flow. That's not how things work. You want that to happen in parallel while your activity is up and running. Now, so whenever an event comes in, that code block will trigger the onEach lambda block that we're passing right there. Okay, that keeps happening, as I mentioned, until we cancel the scope, which cancels the coroutines that we launched under it. All right, so this is kind of wordy, and thankfully there's a little flow extension function that we can use to make this less wordy, as so. So that's just tidying up your code a little bit. It's not so bad to have a scope.launch, but when you have 3 or 4 of them, potentially, that's going to start getting a bit messy, so that's a nice little extension function to use right there. All right, so now we know how to safely combine and consume a flow of view events. The next question becomes, we have view events, how do we turn these into those intents we've been talking about? So, what I'm using here is an intent factory. Now, not only will this intent factory build our intents from the view events, but it will also be responsible for passing those intents along to a model. So, as so. All right. So getting back to our little diagram, before we figure out how to build those MVI intents, we need to figure out what model state will look like, right? We need to know where we're going to be storing and applying this to. Right. So how does this work? Yeah, animations. Sometimes you have to pay attention. All right, so we just need to keep a running count of the number of upvotes in this case, and that's basically what our model is going to be looking like. So we just have hearts and thumbs ups, right? So data classes are really great to store data. As I mentioned earlier, we want everything to be immutable. Data classes are immutable. So that's a very convenient way of storing things. You might be wondering at this stage, how do I go on and apply changes to the model if my data class is immutable? How does that work, right? So data classes in Kotlin, if you're not familiar with them, give you the copy operator. So with that copy operator, what happens is that you create a copy of the existing class, applying one change to it or many changes as you will. So right here, what we're doing is taking the old state, adding 1 to the current count of thumbs ups, and creating a new state from it. So as we go and apply these changes through the copy op function, we're going to have a state that updates and is still immutable and keeps all the nice properties we've been looking for since the beginning, right? So at this point, we have to think about intents. Intents only do one thing. They take an old state and return a new state. So those are usually called reducer functions. So we can see here intent implements a reduce, which takes in the old state and returns a new state out of that. So if we want to implement an intent to increment the heart counter, this is one way to do it. So what we do is simply use the copy function from the data class and pretty much apply the same thing I've just shown you a couple slides back. So if we think back on our events, the conversion of view events to intents with this system looks something like this. It's fairly straightforward. So given all that, this is the full code for the intent factory. Note again that to formalize things a bit, I've created this interface up there, intent factory, that has the process function. It's a suspend function of a certain type, so we can use it anywhere. It's generic. So that's what we're going to be subscribing to. Or rather, what the view events flow will subscribe to. Yeah, basically. Anyway, so the process function will get invoked whenever a new view event is emitted. So by turning that into the appropriate intent and then passing it on over to the update model store, we've just completed the bit in our diagram where we move from view events to intents and then pass along the work and the intents and the reducers to the model store. So the next step in the chain is as follows. Intents, if you think about it, are basically just little functions we're passing around, right? And we want to apply those onto the model. So we're going to need our intent factory to send intents over to the model in some way. So if you look a little bit, we're going to look a little bit at how a model is implemented. So right here, the interface, you can see that's our model store. Suspend fun process, that's where the intents will be coming in. The model state function returns a flow of a generic type, so that's how we're going to get our model state out, right? So right there, we're going to be calling it and moving on to the next slide. So conceptually, a model will do only two things, as I just explained. So the input on one side, the output on the other side. So if we look at the interface, one thing I do want to mention and focus on for a little bit is that the process call here is a suspending function call. So that means that every time that a click happens, that'll be turned into an intent to change the model, and then in turn we call this function. And you might be wondering at this stage, okay, that's nice. So how do we get a streaming model out of this? So we're going to be using Kotlin channels. So channels, if you're not familiar with them, actually, just raise a hand. Who's played around with channels in the audience a little bit? All right, so good. We're going to spend a little bit of time on that, not too much, looking at the clock. So channels, what they allow you to do is basically have two coroutines that will communicate together. At a very basic level, you can think of them as blocking queues. So when you will send an object in there, and on the other end, you'll call receive. And with this type of channel specifically, the simplest builder there, we're building what's called a rendezvous channel. So a rendezvous channel effectively says, when you call send into it, that will be a suspending call up until the moment that somebody else calls receive, which is also a suspending call. And these two have to meet in the middle before that executes and runs through, all right? So we're going to be using something, a second channel in this setup, because it's nice to have the input on one end, but as we'll see, we're going to need to do some operations in between. And when we're broadcasting back out, we're going to need a way to send data to multiple subscribers. So what we're using here is called a conflate broadcast channel. So that's a very fancy name, so I'm going to break it down a little bit. First off, it's a channel. We just went through what that is. So much like the intent channel, you can send stuff in and get stuff back out. The broadcast part is all about having multiple subscribers. So for one value that you're going to send in, it's quite possible for you to have multiple subscribers to this channel that will all get the value that's being passed into it. The conflated bit is all about dropping things to the floor. What I mean by that is if there's more values that come in that can be consumed on the other end, or that if somebody comes in late to the party, they're only going to get the latest available value. So that's what the conflated bit basically brings you here. All right. So we now need to figure out what the glue is going to be between these two channels and why we have them in the first place. So our goal here is to take the series of intents, changing state by applying them one after the other onto the model, and then send the result of this over onto the store channel, that broadcast channel we just created. So here's one line of code that actually is the binding glue for everything. So again, it's kind of a dense one, so we're going to go through it step by step and really break it down so everybody has a clear understanding of what exactly is it doing here. So first off, the store starting state, right, is set at construction time, as you can see below. So when you build that channel, you give it an initial state. Anybody that would be subscribing to this right now would get the starting state, which in our case is 0, 0 on the counters. Next up, when we receive our first intent, the code that's going to be executed here is basically we're calling intents receive in a loop, right? So we're waiting for these values to come in, these intents to come in, so that's going to resolve first. Once we have our intent, what we do is call reduce on it. Remember that intent's only function is the reduce function, and that this function takes in a value, an old value, and will generate a new one. So the little trick we're pulling here is that from the conflated broadcast channel, you can take the current value just by calling .value on it, and that's effectively your old value while you're working on this. So once you're done, you call reduce, you get the new result. So you apply the plus thumbs up right there, and by calling store offer, you're offering a new value onto the store. Now, it's a bit different of a call than send, and the idea here is that when you offer, it comes back immediately and there's no suspension. So that's the way that you can basically just fire and forget at this stage, and things will get solved down the stream and you don't need to think about it anymore. So you've just completed a full reducer loop. We're going to be repeating this for every intent that comes in, and as you can see, the state will evolve in time that way. And there we have it. That's our model store. So this is the final result, like no hidden classes, pretty much all the code is here. So there's a lot going on, but there's not a lot of lines of code, which I'm not a guy that likes to, well, no, wait, I like to play code golf, so I'm pretty proud of this in some sense. But the thing with not too many lines of code is at the end of the day, even if it's a bit complex, this is understandable by a human being in a fairly short amount of time. So I kind of like this pattern. Anyway, so you might wonder why I've been using two channels. Whoa, what's going on? So like I was mentioning earlier, you might be wondering why two channels are involved here, and even maybe why there's a suspend on the process call. So we're not touching on this today, but as you might expect, you're going to be doing some network calls at some point in your applications, right? And it's quite possible that some view events will trigger a network call, which in turn will eventually trigger an intent to change the model, right? And that could be postponed into the future. So we have to be able, ultimately, to handle an intent that comes in from any thread or any context. So this allows us to basically isolate the context and make sure that our main scope is going to be used to reduce values coming in, and we won't have any race conditions, and that things will happen in the right order. All right. So yeah, small note, right now in this presentation, I'm not showing off any network calls because there's already a lot in there, but there are some slow and IO bound calls in the upvote project that I'm going to be linking into the end of the talk. And as time is going now, I was planning on a live demo, but I have to be honest, I'm not too sure we're going to have time for that. So if you're curious to see a little bit how that works and see the pattern evolve as I work more on it, all of that is going to be like updated on the upvote project that we'll see a bit later. Anyway, so when it's all said and done, it's kind of easy to define a typed model store. As you can see at the bottom right here, it's basically a one-liner. So whatever your state is, and your state definition is in your data class, you can just basically get a store for it with this one single call. All right, so we need to close the loop at this stage. We have our model down solid. We know how to convert view events into intents and apply that work onto the model. So we need to hook up our view to the model state observable itself so that it can update itself and show us the results. So this is, if anything, some of the simplest part of the equation, really. So right here, what I'm doing is I'm creating my own little flow extension functions, and we're just taking the values of the store and applying them to a string and showing them on a text string, right, to show the results of this. So at the bottom right here, you can see how to launch that specific flow subscription. So we simply take the model state from our store. We call that extension function on it, creating a flow that will update the screen. And then we launch it in scope. So again, what this amounts to is calling launch from the scope and in a block, just making sure that our flow is going to be consumed, right? And that's pretty much all there is to it. Again, remember that since we're in a coroutine scope, the subscription is going to be naturally disposed of. The coroutine will be canceled when we're at the end of the flow and we're on destroy. All right. So finally, yeah, we're going to have a little bit of time, so maybe we'll go either with questions or the live demo. I have 10 minutes left on the clock. So just for a few seconds, this is the project I keep talking about. So that's the reference. That's the time to take the picture. All the other URLs are in there as well. A lot of documentation. I I'm a bit of a comment beast. I keep getting that as a bad review, basically. But in this case, I think it's going to be useful. So go through that stuff and just look at it, and you'll probably find a few interesting things. And 10 minutes. I think I'm going to go with questions instead of the live demo at this stage. I'm just not going to push my luck too much. All right, so we have microphones on both ends, and if you can walk up to them, otherwise I won't hear you, I'll hear through that, and we'll answer some questions.
So thank you for the presentation.
Thank you.
I have to be honest, I didn't get like 100% of it, so the question could be dumb. Please don't judge me.
That's fair. That's fair. That's fair feedback.
All right. So the question I have is: the model store sounds like more like the state of your data. So does that sort of replace view models in the current paradigm?
So not exactly. Depending on how you implement your MVVM, you would have typically a repository where your state is stored, right?
Right.
Like in this case, it's a very simple example. If I go back a few slides, this is the simplest it can be, so it's like easy not to sort of see it. You have to squint a little bit. View models, in my mind, at this stage, this is where you basically take your state, that's your business sort of domain, right? And you're going to be converting it to something that the view can consume. So this is where you're going to be doing all those transformations. So in a sense, the view model code that you would typically have to massage your data into something that you can show on screen, it's all going to be happening on those subscriptions and these types of extension functions that you would end up having in your view. So nothing forces you to have these living in your view. In my own bigger projects, I've been taking these type of extension functions, which are fully stateless if you look at them, right? Which are kind of, well, no, that one I'm cheating because it has the counter text view. But there's enough, it's easy enough to create functions that will massage the data, get it ready, and just output it to a text view, the class. With extension functions, you can pull these kind of tricks. So you end up with a lot of functional code that knows how to convert your model into properly what I like to call the view model, the stuff that actually gets displayed to the screen. So that's how that layering would work with MVI typically. I hope that answers your question.
To some extent, so the demo project you have, do you use view models at all, or?
So no, like the view models are really a layer, the layer between the view and the model, right. And where the subscriptions happen. Whenever that gets too complicated, I offshoot that work in a separate file.
Got it.
And like the big difference with view models is that you instantiate view models and they have like this state, right? Whereas in this setup, there is no such state. Like the source of truth is your model, everything is a functional transformation, and there are some very interesting benefits to that, because that state can't mutate, you can't mess it up basically.
Right.
Whenever you code that conversion layer, you do it in a way that's very agnostic and reusable. So I found in bigger projects, that's kind of a plus, really.
And just to follow up to that, so could this model store be shared between multiple views?
Yes, so that is something that I've been doing in more complex projects. If you look at the GitHub, another thing to note that there's another MVI project that I've not yet converted to Kotlin and Coroutine and Flow, but that demos this exact point, like having multiple models that interact with each other. At a higher level, it's quite possible to have these models subscribe to one another and interact and cooperate together. Because MVI, at the end of the day, it's all about components that output through a stream and consume to a single function. So when you start thinking about it that way, it's quite easy to compose these elements together and get more complex behavior out of all of that, all the while keeping the benefit of keeping that business code only concerned with its own component.
Thank you.
Thank you.
Hi, not sure if you can hear me okay?
Yeah, go for it.
Hi, I guess your last part of your answer there might be partly answers to this question, but like a lot of people, if we're using Android architecture components and we're using MVVM, for example, and we're using Android view model and live data, for example, I guess, the officially Google, sort of provided solution.
Right.
I suppose, this is very interesting, by the way, but I'm still struggling to understand how maybe I couldn't achieve something very similar using the sort of those officially prescribed components and approaches.
Right, and that's a fair comment as well. Like, I've seen some MVIs built using view models, live data, and other architectural components that you get from Google. What's kind of interesting for MVI for me is that you get to decide which ones you actually want to use. View models are totally usable in this context, but you have to wonder sometimes, like for me, I found that in my own production apps that have done MVI with RxJava, not with coroutines, but they're effectively, structurally it's the same kind of stuff. We did not need to go and use view models because we had like a simple enough way of dealing with that stuff. But the benefits, the most benefits I think you get, well that's again, personal opinion. I'm not trying to preach against one or the other. What I'm saying effectively is you can totally use these components and they are useful in the context of lifecycle management, right? Because that's the big thing they bring to the table. So whenever you start mucking around with things, just like for example, a scope that you would like to cancel so that your views stop updating whenever you're on a different screen or you're context switching or whatever, then these components are super useful to trigger the lifecycle changes in question. So you might very well end up, depending on what you choose to use in your full app, with a view model that has the coroutine scopes that are sort of basically setting up this tubing I've just shown, and that are controlling the lifecycle of it in a finer grained manner. So, yeah. And you might see, yeah, that's about, yeah.
That's great, thank you.
Anyone else? All right, I'm going to call it. So feel free to come and see me if you have any other questions. So thank you very much for being here. It was a pleasure to be here.